聞こえますか ?OK。
Hi, good afternoon, everyone. So my name is Nur Saiful Azam. I'm a third-year doctoral student under NLP group, currently researching on multimodal detection of cyberbullying using memes, integrating transformer-based text analysis and vision transformer. As you all know, that my research is on combating cyberbullying on the internet. While cyberbullying is a growing issue in online spaces, conveying harmful messages using text seems to not be enough for them. They currently move into another means, which is creating memes that once funny to become more toxic. With the rise of toxic memes, it has become easier to weaponize humor and imagery to target individuals, causing harm and harassment. Memes, due to their viral nature, spread rapidly, allowing this toxicity to multiply exponentially. In these studies, we focus on how toxic meme can cause cyberbullying and the unique challenge that they pose for automated detection system. So these are English version of Japanese. Apparently, Japanese meme and English meme are quite different. What you see here is a English meme. It contains both image and text in a single image. The text and the image have their own meanings, but with them combined together, it creates a unique meaning. So why it's related to cyberbullying? Because they weaponize humor and imagery to target and harm individuals. Also, the viral nature of the memes with rapid spreading and creates culture of online harassment. And also, there are sensitive memes. They've always been targeted by who disagree with the content or find it offensive, and create a pretext to attack the creator, character, or beliefs. So there are many cyberbullying detection models across the internet. However, memes add new challenges. They often contain mixed signal, text and image that are combined create a different meanings that rather than seeing them alone. In this multi-context nature, memes, we need a model that can understand text and imagery together rather than in isolation. So for the literature review, I focus on both text-based and vision-based detection method to combine both model and make a multimodality model. For the text-based, the researcher work on hate speech detection and fine-tune BERT model on large data set of facing language. In my previous research as well, I used electron model with an addition of part of speech text in order to improve cyberbullying detection. These two research mainly focus on the text data sets. For vision-based detection, the researcher demonstrate how transformer capture local and global pattern in the image, which is essential for detection toxic visual element in memes, in which are important in the study because we need the capability of a vision transformer to detect toxic images. So the literature review shows a clear gap that text-only models are not enough because they cannot see the image. And image-only models are not enough because they could not see the text. The real gap is detecting toxicity that only appears when you combine the text and the images. Like example I showed, therefore, we propose a new method of combining the text and vision transformer and make it multimodal. So my methodology involves data collection and pre-processing. We collect toxic memes dataset from the internet, applying OCR if needed, and picture scaling to be processed with the model. We use Vision Transformer to fine-tune toxic meme dataset and text-based transformers such as BERT or for fine-tuning text dataset. Finally, we test the model on the random sample to see how our model can handle an unseen image. Here are the rough visual representation of structure for creating multimodal that involve text and visual. For the top part, it's how we fine-tune and pre-process the text dataset, and the bottom part is how we pre-process and fine-tune image. And finally, at the end, we combine their features on the last layer and produce a result. So far, we use two main datasets: Facebook hateful meme dataset. This dataset released by Facebook to benchmark model in detecting multimodal hate speech. It contains 10,000 memes, 5,000 are hateful and 5,000 are non-hateful. A balanced dataset that is useful for evaluating performance of the model. A second one, we use Innopolis hateful dataset similar to Facebook, but this dataset has been created in Innopolis University for detection of multimodal hate speech. It contains 20,000 memes and 2,567 are hateful and 70,745 are non-hateful. They say to be a similar distribution of real-world dataset. So I have fine-tuned two datasets on two Vision Transformer model, totaling 4 models, which are first two are base model with patch 16 by 16 pixel. It used 16 by 16 pixel to capture spatial relationship and contextual information across an image. We also resize the image to a resolution of 224 by 224. The other two is on the large model with same patch of 16 by 16, but different resolution with 384 by 384, which is large so that the model could capture more information across the image. We also decided to add a syntactic augmentation to further increase the training data. The augmentation includes random horizontal flip, random rotation up to 30 degrees, color jitters, and random resize crop. The result for VIT for the base Vision Transformer model on the that has been fine-tuned on the Facebook hateful meme dataset is not convincing. We found that the Vision Transformer with augmented data and hyperparameter tune gives the best macro average and F1 positive, but drop in performance for F1 negative. The result for large version of Vision Transformer model fine-tuned on Facebook hateful meme dataset is also it's not conclusive. The result shows that the best macro average goes to Vision Transformer baseline without any augmentation and hyperparameter tuning. The Vision augmented plus hyperparameter tuning are able to detect F1 positive better compared to the baseline. For Innopolis hateful meme dataset, here are the result. Here where the result get confusing. While the Vision Transformer augmented and hyperparameter tuned have the best macro average F1, the Vision Transformer baseline is still have a better performance on detecting F1 positive. Similarly to the large model, apparently without the hyperparameter tuning, large Vision Transformer model have the best macro average F1 score, and VIT augmented plus hyperparameter tuning have the lowest score against the other model. The model also have the lowest F1 positive for detecting toxic images. So what has happened here? I think it's because the Innopolis hateful meme dataset, the dataset is severely imbalanced, that the model could not learn the trait or feature of toxicity in this dataset, thus reduce its performance. So for the Roberta model, we also decide to add more training data by adding description column in the text dataset, which is generated by Moondream. What is Moondream? Moondream is a vision language model designed to generate text description from inserted image. The generated text description from inserted image. The generated text then has been included to the text dataset to give meanings to the original text. Then it goes to the T5 paraphraser, where it adds more training data by paraphrasing both the original text and description to increase the training data. Once that has been done, data processed by Roberta base and large model. The Facebook hateful memes, the result looks unstable. Roberta Moondream achieved the lowest score on the base model, but the large model achieved almost perfect. No, this is sorry. So the Roberta model trained fine-tuned on Facebook hateful memes get like the highest score with 0.7076, and for the large model with 0.7169. Apparently, T5 dropped in performance because probably with the extra information, it dilutes the toxicity or the meaning from the images and text. So similarly, for the Innopolis hateful memes dataset, the Roberta and Moondream achieved the highest macro average score with 0.7621, and Roberta, for the large model, I achieved 0.7599. So for the proposed model, we combine text model Roberta and Vision Transformer and feature contentation in the last layer using hyperparameter that used in the uni model. So we can see that for Facebook hateful memes, Robervid plus Moondream achieved the macro average F1 score the highest with 0.6870, and for the large model with 0.6892. And for the Innopolis hateful meme dataset, the Robervid plus Moondream achieved the highest with 0.7825, and for the large model, Robervid plus Moondream with macro average of 0.7825. So overall result shows the comparison in between uni models and Robervid multimodal. As you can see that Roberta model is still the best model compared to the multimodal. Is it because the dataset is small for the two models to learn, or maybe the Facebook dataset toxicity might be primarily text-based, and the image may not add any useful information? For this dataset, adding image is just adding like a noise, which confuses the model and make the performance worse. For the Innopolis hateful meme dataset, the dataset, as you can see that the Robervid performed quite well in this case and are able to beat the uni model on the macro average score. More in-depth analysis needed to be conducted in order to find why the Facebook hateful meme dataset, Robervid doesn't perform on Facebook hateful meme dataset as expected. So in conclusion, combining both and text images prove to have improvement, but only for Innopolis hateful memes. There are more analysis needed to be done for Facebook hateful memes on why the model has failed to improve. And we can see that from the result that text remains the primary driver for the toxicity, and the image description from Moondream actually helps to improve the result. So what's next for this research? So we need to do a deeper analysis on why Robervid failed on Facebook hateful meme datasets by using an explainable AI such as Lime or Sharp. And we also wanted to compare this model with other similar model And also, lastly, we would like to compare this model with LLM such as Lava or Mistral and the others. Thank you for listening. If you have any questions, please.
はい、発表ありがとうございました。何か質問ある方お願いします。
Yeah, so I have one observation and also one suggestion.
Yeah.
Like, since you actually mentioned, we're not going to explore with respect to the explainable AI.
Oh, okay, speak.
Yeah. So, like, since you actually told that you'll be like exploring the explainable AI.
Yes.
Exploring why it is actually working or not working.
Yeah.
Maybe like one option is like whatever the text that we are actually generating out of the movie.
Yeah.
Can be like semantically compared with the text that you're actually like getting from the, which you're actually passing to the robot. That pretty similarly can be measured on like how the themes in the textbooks now why it is not in the like in Innopolis data can be like also.
Okay. Okay.
Yeah.
Yeah.
Another is actually like a sub question. Like here also like a kind of like late fusion we're actually doing on the features that we're actually pulling from the last layer. And on based on any empirical experiment, it's been decided, or like it's a general approach we're actually following. Which one? So.
Oh, sorry. What was that? So what I did is like we take the features on the last layer and then combine them together. And they produce a result.
So it's actually like you're taking from the CLS.
Yes, the CLS class, yes.
And when we're actually doing for the fine tuning, how many are we fine tuning the layers or like whatever the additional final layers you have added around would be like fine tuning?
I don't think I added any like final layers and everything, so I just used like Roberta and the Vision Transformer final layers and some combine them and then actually produce a result.
Okay, so like how many layers that you're trying for retraining will be freeze?
Not rich, but yeah, I'll check it and then go and see. Yeah.
僕からいいですか。
はい。
なんかすごい初歩的な質問になるかもしれないんですけど、
はい。
画像とテキストは別のエンコーダーを使ってるんですよね。
はい。
で、最終的に特徴量を統合してるってことなんです。
最終でもう一回、すみません。
テキストと
はい。
画像のエンコーダーがあって、
はい。で、その後が、なんか最後のレイヤーが、なんか組み合わせて、で、その後が結果出る。
はいはいはい。なんか、クリップとかわかります？
クリップ、クリップモデル。はいはい。
あれだと、その、最後に統合するみたいなことを、なんかしなくてもいいじゃないですけど。
いや、なんか、つまり、なんかちょっと違うみたい。
そうですか。
なんかこれがなんか別の方法もある感じ。なんか2つ、3つぐらいかな。なんか方法がある。なんかこれの、なんか最後のレイヤーでなんか使って、多分クリップはもう一個、なんか、もう一個モデル使って、その後組み合わせるみたい。最後なんか分類のモデルが使うかな。
わかりました。今回は今のこれだ。
そう。
はい、わかりました。ありがとうございます。はい。時間何分まででしたっけ？25。あと5分ぐらいあるので。
Okay, so I just have a few suggestions. First of all, I think you just tried with robot and diffusion of robot and behavior transformer, right?
Yeah.
So in some papers so far, I did know that like as we are pretty much noisy, so to extract features from read text properly, sometimes a BSC model and debugger model works pretty much better. Even if you just use the BSC model just for inference only, even without fine tuning, it still works pretty much better rather than the BSC model. So you can try that. And for the one question from Mr. Barathi, that you just take features from the last layer, the CLS layer, right? So you can also try like to take like some like you can apply some fully built type of approach to take like mean feature from all the layers. This might be better because mean text are pretty much noisy, and if we just remove image features from mean text, those texts simply doesn't make any sense. So if you get features like mean feature from all the layers, it might represent better.
Okay. Yeah, I get that.
Okay, so although you did some practice, yeah, you really need to work a little bit more, especially since you're basically on your straight line to the end of the PhD, right? So basically, right now, every presentation you do, you should probably think about it as a sort of practice for the final presentation, right? And for this, there's a lot of things that you need to think about and correct in the presentation. And well, first of all, we need to have a better introduction. So you only say like very general and like not specific things about memes. Like, there are many memes, and before cyberbullying was mostly by text, right now with memes, but there are no information about this, right? So for example, how in the online communication, how much is how much of the message, like the ratio of messages, contain only text with memes, and memes only, for example, right? I'm sure there is some kind of analysis statistics about it.
Yeah.
And also like in general, like maybe you could think about the overall communication, like change of communication on the internet. So for example, in the, let's say, 90s and early 2000s, text was the main part. But right now, what is the main sort of way of expression is like TikTok, right? Short videos,
Yeah.
or basically in general visual information, right? And even you can check that even job hunters, or when you're doing job hunting, companies will ask you to prepare a 15-second video, like TikTok video about yourself. That's also a new trend, right? So not sending a CD as well, but not just CD, but also like a TikTok video about this. So this is a very new trend. So basically everyone is switching into visual communication. So that's very important, right? Okay, but this is like a general introduction. Let's actually go to yeah, I wanted to check about the results. So before you had this strange problem that precision and recall didn't add up to the Excel.
Yeah.
Do you still have it, or did you check?
Yeah, I changed.
Okay. So changed it, but do you know what the problem was?
Yeah, because the problem is that I took weighted average for precision and not the macro average one, and after like checking everything, so I should be taking on the macro average for precision and recall, and that's how we get basically macro average for
Okay.
one.
So if you want to use weighted average F score, weighted F score, it's okay, but you will have to explain it, right?
Yeah.
Okay, yeah, and about this confusion about what is positive, what is negative, like this.
Yeah, that one is also correct.
Okay.
It's just that I mistakenly labeled for like precision is negative.
Okay, so from now on, maybe you can from time to time just have a random presentation just for practice, because just like let's say Barathi asks a question and your first answer was I don't have information, I have to check it, right?
Yeah.
So we need to get rid of all of those I'll check that later answers. Because if you say something like that during the final PhD presentation, that means, well, okay, then you'll have to graduate in 6 months, right? So you'll have to prepare this information.
Yeah.
So yeah, so just for your own good, for your own need, maybe from time to time have like a presentation about your research.
All right.
Okay, thank you.
Thank you.
はい、じゃあ時間になったので、これで終了にします。もう一度、サイフル
大丈夫ですかな大丈夫かなこれ大丈夫かなOK です。OK です。
はい、じゃあ、瀬川さん発表お願いします。
はい。はい。カーリングの、ですね。カーリングのデリバリー動作と熟練度の関係の分析と題しまして、麦の瀬川が発表させていただきます。はい。目次は、研究背景、研究目的の次に、グラフを2種類見せるので、そのグラフの出し方が2通りあったので、研究方法、結果、で、研究方法、結果って、丸1、丸2の順番でいった後に考察の順番でいきたいと思います。はい。まず研究背景からです。はい。下の方で、動画を流していますが、デリバリー動作、カーリングにはデリバリー動作とスイーピング動作という主に2つの動作があります。で、私の注目している動作の方はデリバリー動作ですが、下の動画のように表情でストーンを押し出して滑らせる基本動作になります。安定性と再現性というこの2つのポイントがショット、ストーンを投げる動作、ショットの正確性に直接影響するため、競技力向上の根幹要素と考えています。はい。で、人間はまず筋力だったり体格、関節可動域といったところで個人差があります。はい、そのため、デリバリーフォームの習得だったり改良を目的とし、たくさんの練習をする必要がありますが、初心者や中級者になってくると上達するために多くの試行錯誤を強いられているのが現状です。はい。カーリングは表情で体をコントロールする必要があるスポーツですが、その時設置しているところが、ブラシとストーンと足になるんですが、その中でも側圧を変化させることで バランスをとっているのではないかというところに着目し、研究を進めています。研究目的は2つになります。熟練度別単位の把握と初心者の誤差パターン抽出の2つになりますが、熟練度別差異の把握を簡単に言い換えますと、初心者、中級者、上級者という熟練度があるとして、その中でも、何かこう動作に違いがあるんじゃないかというところを把握することになります。初心者の誤差パターン抽出というのは、初心者に共通して何らかの特徴があるはずなので、そこを見つけないといけないよなっていうのが研究目的になっています。今回の発表は上の方の熟練度別単位の把握について触れながら説明していきます。はい、で研究方法、これまず1の方ですね。はい、でこちら、被験者がまず示している通り、熟練度1、2、3という3段階に分けて、各それぞれ3名、合計9名の方からデータをいただいております。はい、使用機材はペダと呼ばれるものを使用しました。データ収集方法ですが、このペダを被験者の両足に装着します。装着してもらった状態で1セットを10指向とし、セット間に5分間の休憩を設けています。その状態で3セット、データをいただいたので、合計1被験者から合計30データ収集しております。はい、この機材を用いた理由ですが、熟練度の違いによる側圧分布の違いを明確にするためになります。はい、また動画になりますが、実際にペダを用いて取れるデータがこちらの側圧可視化図になります。足の裏を表している動画になりますが、足の裏に小さな点が動いているのがわかると思います。こちらは圧力中心と呼ばれるものになりますが、英語にするとセンターオブプレスとなります。センターオブプレスの頭文字を取ったものを COP と呼びますが、COP のこの動きに違いがあることがわかると思います。この COP の動く幅だったり動き方というところから、デリバリー動作時の側圧の安定性、または再現性について触れていきます。はい、また、実際に出力される Excel データの一例を挙げます。左側から時間データですね。で、左足のデータと右足のデータがこのように出力されます。左足と右足のデータは左から、圧力、真ん中が COP の X 方向、横方向の動きで、最後のものが COP の Y 方向の動きになっています。このデータを用いることでグラフを作成しています。また、等間隔で11点を取得と書いていますが、この部分は後ほど説明しますが、等間隔で11点を取得することで、こういったような箱ひげ図を用いたグラフを作成しています。こちらは後ほど説明いたします。はい。で、等間隔で11点取得するといったんですが、その区間を設定しないとデリバリー動作というものは、被験者によって動作時間も違えば、被験者1人に対しても、毎回同じ動作を同じ時間でできないため、区間を設けることでデータの正規化を図りました。はい、まず、デリバリー動作はこのようにストーンを持った状態で足を引く動作から始まります。この姿勢を動作前としました。はい、この姿勢からストーンを押し出して滑り出しますが、ハックと呼ばれる黒い蹴り台を蹴り出すことでストーンを投げます。この蹴り台から足が離れる瞬間を蹴り出しとし、この動作前から蹴り出しの間の区間を区間1として、データの正規化を図りました。先ほどの11点抽出したのは、そのデータの正規化のために特徴点を11点抽出しています。これを被験者ごとに各30データずつやって作成されたグラフがこれになります。被験者9名のものを合わせているのでちょっと見づらいと思いますが、グラフの見方を説明しますと、X 方向の区切り点と書いているものは先ほどの11点抽出したものになります。で、Y 軸の見方ですが、0から90という値があると思いますが、値が大きくなるほど、小指側、値が小さくなるほど親指側と書いてありますが、こちらのグラフは左足のみのデータになっていますので、左足の COP の X 方向、横方向の動き のグラフになっています。そのため、値が大きくなるほど COP が小指側に動いている。だったり、値が小さくなっているほど親指側に COP が動いていると思っていただければいいと思います。はい。で、各被験者9名のグラフの特徴からフェーズ分けをしました。上の方に蹴り出し直前フェーズ、荷重調整フェーズ、荷重安定フェーズというふうに区切り点1から4、5から9、10、11というふうに分けてあると思いますが、フェーズ分けをしました。フェーズの名前が長いため、今後はフェーズ初期、フェーズ中期、フェーズ後期というふうに呼ばせていただきます。で、結果1からですが、この9名のデータで見ていくと見づらいため、被験者 A と比べながら、各被験者のデータを見ていきます。はい、まず被験者 A の特徴ですが、区切り点1から6、そのフェーズ初期からフェーズ中期の初めのところは直線的な変化をしていました。その後、フェーズ中期からフェーズ後期にかけては右肩上がりの変化を示していたのが被験者 A でした。はい、被験者 A と似たような特徴だった3名が被験者 B、C、D の3名になります。被験者 B、C、D はフェーズ初期と後期のところにおいては被験者 A と同様に箱ひげ図箱ひげ図のひげの長さが小さくなっているので再現性がここは被験者 A と同様高くなっていました。ですが、フェーズ中期の赤い箱で囲ってあるところですね。囲ってあるところが被験者によって箱ひげ図の箱のサイズだったり、ひげのサイズが異なっているので、この部分で再現性に違いが現れたのかなというふうに考えます。はい、次に、被験者 E と F の2名になります。被験者 E と F の2名は、被験者 A と比較すると、フェーズ初期、後期のところは同様に再現性が高かったかなというふうに考えます。でフェーズ中期のところですが、一度値を低くしてから上げたりだとか、まず、グラフの形が違うのもありますが、フェーズ中期のところで箱ひげ図が特に大きくなっているので、この部分で再現性が低くなっている、被験者へと比べて低くなっているということが分かります。はい、最後に熟練度3の3名、被験者 GHI の3名ですが、この3名に関しましては、フェーズ初期だったり後期のところですでに箱ひげ図の大きさが被験者へと比べて大きくなっているので、この部分がすでに再現性が低くなっています。結果1のまとめです。被験者間で違いが現れたのは、特にフェーズ中期でありました。区間1においては、被験者 ABC と被験者 D は COPX の変化が少なかったです。で被験者 EF の2名は被験者 ABC と比べると大きな違いは特にありませんでしたが、COPX の変化が被験者 A と比べて少し大きくなっていました。被験者 GHI の3名はフェーズ中期とフェーズ後期の COPX の変化が大きくなっていました。はい、次に研究方法2の方です。はい、先ほどと同様のデータを使用しています。このデータから初期値を0としたグラフを作成し、30指向を取ったと言ったんですが、1から10指向によるデータの比較をしました。はい、このグラフだけだと、ちょっとジグザグしているところが邪魔というか、ちょっと見づらくなっちゃうので、移動平均を取ることで、ノイズを、このジグザグしているのがノイズなので、ノイズを閉鎖化することで、特徴を見比べていきます。で移動平均を取るときは、窓幅は10にしています。はい、実際にこのグラフを代表にしながらまた見比べていきます。こちらは被験者 B のデータになりますが、簡単に説明していきますと、初期値から一度値を下げて、値をその後右肩上がりに上げているのがこのグラフの特徴です。このグラフが何を表しているかですが、時間経過による左足の圧力の変化になります。なので被験者 B は動作を始めてから蹴り出すまでの段階で一度左足の圧力を下げてその後ある一定のところから右肩上がりに上昇させているのがこの被験者の特徴になります。はい。 はい、そちらと比べていくと、同様に初期値から値を一度下げて、その後右肩上がりに上げているような特徴があったのはこの4名でした。熟練度1の2名と熟練度2の2名になります。この4名はグラフの形状に個人差は、グラフの形に違いがあるため個人差はありますが、初期値から値を低下させて、その後右肩上がりに上昇させていくという特徴は被験者 B と共通していました。はい、被験者 B のグラフと特徴が一致してなかったのがこの4名になります。左上が熟練度2の1名。で、他3名が熟練度3の3名になります。熟練度2に関しましては、ちょっと見づらいです。初期値から低下しないが、右肩上がり、初期値から低下するフェーズはあまり見られなかったんですが、最後の方のところは右肩上がりの上昇が見られるグラフの形になっていました。はい、で熟練度3は他の熟練度と比べて1から10指向までのグラフの形状にそもそも違いが、全部同じような動きではなく違いがありました。でどのような違いかというと、初期値から値が上昇しているもの、一度下がってから上がるのではなくて、最初から上昇しているものがいくつかあるというのが熟練度3の特徴になります。このことから熟練度3は側圧の左足の圧力というところでは再現性が低いのかなというふうに考えます。結果2のまとめになります。被験者によって測定圧力の変化に違いがありました。カーリング歴のあるものは基本的に左足の圧力を一度低下させ、その後緩やかに左足の圧力を上昇させるような変化を見せました。で区間1において被験者 ABC と被験者 DE の5名は初期値から一度圧力を低下させ、その後右肩上がりの変化を見せました。で被験者 F1 名に関しましては、その低下させる段階はなかったものの、ある一定のところから右肩上がりの変化を見せるグラフになっていました。で被験者 GHI の3名は毎回の測定圧力の変化に違いがありました。はい、このことから考察です。熟練度に応じて蹴り出し時の荷重パターンに明確な差異が存在しました。特にフェーズ中期において、それが見られ、熟練度間で顕著な違いが確認されました。これは経験値による違いなのではないかなというふうに考えます。また、初心者のみフェーズ中期とフェーズ後期の COP の X 方向、横方向の変化が大きかったです。これらは乗り込みの過程で初心者は再現性が低くなっていることを示唆しています。また、被験者によって測定圧力の再現性に違いがありました。測定圧力の再現性が競技動作の再現性に影響するのではというところから、表情に乗り込む過程の再現性の向上が競技力向上につながるのではないかと考えます。今後の展望になります。ご清聴ありがとうございました。
はい、発表ありがとうございます。何か質問等あればいらっしゃいますか。いいですか。
はい。
ちょっともしかしたら先の話になっちゃうかもしれないんですけど、熟練度の高い人とそうでない人で違いが分かったと思うんですけど、じゃあ、その初心者の方が、なんでしょう、デリバリー動作を安定して行うようになるにはどうしたらいいと思いますか。ちょっと先のことだと思うんですけど。
そうですね。もともとはそこにたどり着くのが本来のゴールだったんですけど、そこにたどり着くために、どういうですね。どうしたらうまくなりますかってことですか。結局のと
このデータを使って、今のものだと、上手い人とそうでない人の差が分かるっていうことだと思うんですよ。で、その差を埋めることがもともとの目的だと思うんですね。
そうですね。
で、差がはっきりとデータで分かる方が、最短距離でその差を埋められるっていうことなんじゃないかなって思ったんですよ。でそのなんか方法みたいなのってイメージとかでいいと思うんですけど、例えばなんか こういう練習をした方がより上手くなるみたいなところまでなんか踏み込んでたらすごい面白そうだなと思ったので、何かそういうアイデアでもいいので何かあれば。
アイデア。一応、去年の段階かなにちらほら出たのは、こう平均台の上でバランスをとってみるだとか、氷の上じゃなくて、一旦陸の上でそういう姿勢を取るっていうのを複数回投げる前にやるだとかっていうのをやると、こう姿勢を、なんていうんですかね、イメージ、氷の上でいきなりやるとすぐできないので、それを別のとこでやるみたいなのはありましたね。で、この結果から、まあ、一つ言っていいかわかんないですけど、言えるとしたら、そのやっぱ乗り込みのところ、左足を引いてから前にこう蹴り出していく。この段階で、やっぱり初心者がここ再現性が低くなるので、この段階をよりこう再現性が高くなるトレーニング。ちょっと何かはまだわかんないですけど、そこを高められるトレーニングがあれば、比較的こう上達のスピードが上がっていくのかなっていうのは考えています。
わかりました。ありがとうございます。はい。他に何か質問ある方いらっしゃいますか？
最後の結果で、熟練度が高い方が、再現性が低いっていうで、
最後、ここですか？あ、はい。
これは
熟練度が高い。
3っていう。
熟練度さん、これ初心者の方。はい。そうですね。一応想定通りのものがこう形になった、グラフになった。はい。
他に質問ある方いらっしゃいますか？じゃあいいですか？
はい。
これ、グラフの形状で違いがあるっていうふうに結論付けてるっていうことであったんですか？
そうですね。なので、こう数値データがあるとかではなくて、このグラフの、目視情報じゃないですけど、目で見て、似てるよね、似てないよねの世界にはちょっとなっちゃうんですけど、比べるともう結構明らかっていうか、これ言ってしまったらどちらも上級者、中級者なんですけど、上級者はもう毎回こう一度下げて、U の字みたいな変化。序盤の方で説明した動作前からこう蹴り出しの乗り込んでいく時の左足、滑らせてる方の左足の圧力が、簡単に言ったら一回圧力かかってる状態からかからなくなって乗り込んだ段階でかかるから U の字になってるんですよね。これが初心者になるとこの右側と下の2個ですけど、U の字になるのが正解じゃないですけど、上級者、中級者は U の字に基本なってるのに、初心者がなってないっていうことは、そういうことだよねみたいなのをこう目視で見せるためにこういうグラフにしてた。
それもなんか再現性ではなく、なんか動作の方法による違いなのかなと思ったんですけど、なんかじゃあ中級者と上級者、家系同じだと思うんですけど、おそらく上級者の方が再現性は高いはずですよね。その点を数字でなんか示すのが、じゃあ次のやることってことなんですか？
そうですね。自分の中でその数字で示したいのはあるんですけど、わかんない。やってみないとわかんないんですけど、数字で示すってなると、この正解があって、それに正解に近いか遠いかみたいなのを0から100でこう出すのが一番早いじゃないですか。例えば、被験者 B と比べたから、この被験者 B の波形、これを正解データとして、 これがどんくらい一致してるかみたいに出せば、まあ、その再現性が高いか低いかって数値で出るじゃないですか。そういう数値じゃなくて。
いや、その個人の中でどれだけばらけてるかっていうのが再現性の高さ低さなんじゃないですか。
あ、そう、そうですね。でもその再現性を仮に出す場合、1個正解データがないと、その正解を再現できてるかっていうお話にこうなってくるので、かつ、そのデリバリー動作ってこう毎回異なってきちゃうので、これを正解っていうふうにこっちで指定していいものなのかどうかって考えると、仮にやろうと思ったら、例えば1個目、1データ目を正解として、他10データを比べた場合、どれだけ近いか遠いかっていうのをやれば、多分その辺は数値で出せると思います。
わかりました。ありがとうございます。はい。他に何か質問ある方いらっしゃいますか？はい。じゃあちょっと早いですが、一旦これで、はい。
はい。
終了にしようかなと思います。
はい。
はい。もう一度瀬川さんに拍手お願いします。
どうでしょう。大丈夫。
Check, check. Check, check.
OK。はい。では、また発表お願いします。
So, very good afternoon, everyone. So, I'm myself Barathi Ganesh, doing first year doctorate under Professor Mikal. And my proposed research statement is M3LM, it's abbreviated one. So, multimodal, multilingual, multitask language model is the full name. So, before getting into the actual problem statement, considering the wider audience, I would like to start with what is multimodal. So, multimodal is basically an algorithm handling a different kind of data modality, input, output, or maybe like something together. So, like here you can see the input we have text, audio, image, and the video, as well as the output. It can be like any combinations can go. And about multilingual, when this algorithm handles more than one or actually like more language, then it becomes a multilingual. Multitask, the algorithm not only like does the specific task, but it actually like perform more than one or two or more tasks. So like here in the example, this like stated as can perform a classification, summarization, extraction, and translation. Now, knowing this, like what is the need for this multitask, multilingual, and multimodal AI? Okay. So few might have already observed in this presentation, few of our projects are focused on handling multimodal data. Okay. That is like shows the demand for these models. And also like it could be observed on the proprietary models like ChatGPT, Gemini, and Perplexity, how it actually like when it is actually switches the each major versions, how they actually like observed or included different modality into them to provide more knowledge. And similar to the proprietary models, there are actually open source transformer models also, when it has actually started from the base models. Now 2.5 can actually like handle more than 3 modalities. And similarly, we know Gemma from the Google. Another aspect of the Gemma, different from the one is can be deployed in edge devices also. And another model is from the Meta, Seamless Reality. Unlike the previous two, the Seamless M40, it's not actually like for the generic task, it's for specific task of doing translation or transcription. So this shows the demand. And this shows the market share, like how it is actually has the business value. So the generic market is actually like every year around 13%, it is actually like growing. And it is expected to be like almost like existing 40% of the generic solutions would be multimodal by 2027. And notable point is like the fastest growing segment is actually Indian language, because like there are more than 400 million speakers out there. So due to that, there are more opportunity. But the thing is like the current AI penetration is actually like 2 to 8%. So there are like more chance for like having such solutions. So I would like to propose this problem statement only. Developing a multilingual natural language processing modules that can actually work on the standalone as well as cloud-based models, which can work offline with the near real-time latency for 35 languages. Okay. So why we specifically mentioning the 35 languages? I would like to go with the depth-first approach than the breadth-first. So for example, if we take the ChatGPT or like any other proprietary models, so they're actually focused on more language. Due to that, the knowledge distillation is happening more. In order to avoid, to increase the more accuracy or like practical usability, we'd like to go with the depth-first approach. So what are the tasks that you would like to work on is having a single model which can actually like does text translation, extracting information from the text, and in the inference side, it's like classification, text classification. And the voice models will be like speech to text transcription, speech to speech translation, as well as like speech classification. And we can do the speech identification also with the model. And the final one is like, given the text, we can actually generate the audio. So considering that, for here, I will be like handling the 2 modalities only. That will be like text and the audio, as well as the output also text and the audio. For example, when we do speech-to-speech translation, so the input would be the speech in one language, and the output would be a speech in another language. Or when we want to do a speech-to-text transcription, input would be the speech, the output would be text. Or when we want to do text-to-speech generation, the input would be text, the output would be an audio file. So one single model can actually like handle multiple modalities. So that is the objective. So for that, when we actually done the initial technical survey, the observations are currently like these problems are handled through the cascaded approach. So when we say cascaded approach, it would be like multiple models stretched together to like serve something. For example, when we want to do speech-to-speech translation, currently how it's been actually used is first, either they use the whisper kind of model to generate the text from the audio file or directly translate to another language, then use an additional TTS model on top of that to generate the speech at the output. But when we actually like follow such things, what happens is like the cascaded, like it will propagate the error. The error happening in one stage, so obviously is propagated to the next level. So end result will be like kind of like the error output only. Another result also like shows that this cascaded approach is actually like character level F-point degradation happening more than the end-to-end model. Then, since we're actually having multiple models, handling them in a practical use cases, also like scaling them towards the different languages or shows like more complex. Then, obviously, like since we're having like more models and stitched it together, the latency of processing the information from one model to another model is actually like scaling. It has actually increased one. Then the other observations, those were actually made is that is the crisis for low resource and ending languages data sources, which is actually like made this model not to scale towards the low resource languages. For example, if we take any of the latest models, the standard word error rate is actually for low resource languages 25 to 40%. And when it is actually goes to the extremely low resource languages, this increases further more. Because since these models are actually like in few tens of billion parameters, what happens is like the need for the data is also like increases. So that is one of the reasons. Then finally, all these current models are actually like trained on the raw data, which is not actually like biased. It's not handled the bias. Due to that, any recent models, even if we take and go, that will be either be biased towards the gender. For example, 80% of the data is actually like has the male content than the female content. That is one of the observation, and it is actually like has the bias towards the accent that is spoken as well as the language. So by observing this market demand as well as the technical demand, so this is the initial proposal I'm trying to explain. So I'm proposing a unified model, so where we can actually like use the single model to perform the above mentioned 8 tasks. Okay, so the input would be like, if you can see audio file or the text, we can actually give either one of it. For example, if we do an audio to audio translation, so we'll be like providing like an audio file, and we have a voice encoder, which basically like understand what is spoken inside the audio file. Then we have a length adapter that is actually like an additional layer to have the alignment between the speech and the text. Then we have the text decoder. So whichever the output formats that we want. Suppose if we want to do any classification, the text decoder along with the adapter, it will do the classification. Or when you want to generate the text, so you can actually like generate the character embeddings, which can actually comes to the other end of the vocoder for generating the audio. But when you want to actually do the text classification, it will go through the text encoder, which will actually understand what is given in the text, and adding a decoder. The decoder on top of that, we have a separate adapter for the classification. It can do the classification. So this architecture is still under the construction, so we will be discussing on the upcoming slides. But about this, the architecture is it can actually handle the different language. That's how it is actually like designed, and it has a parameter of 1.7 billion parameters. And when it want to handle the 1024 tokens, it can actually like take 3.6 teraflops on a standard RTX 4090 machine. So it is more suitable for real-time application as well. So it's a sample like how the data is actually looks to train this model. Single data schema for training multiple tasks. So about the model, like the text encoder, we'll be like taking Google's MATLAB 400 models to fine-tune it. Why we actually like choosing it? It's already like pre-trained on 400 languages. So due to that, it can actually handle more diverse language things. And the voice encoder, we're taking Wave2Web 2.0, so which is also like trained on 4K audio in a supervised manner, and many levels of data, audio data in an unsupervised manner. So in the phonetical level as well as like in the linguistic level, it captures personal information. Then text decoder, we're using again MATLAB 400 as a decoder architecture, because like it's the text to text decoder. So with that, we can actually perform a number of tasks related to the text. We can do extractor as well as summarization as well as classification. So this portion actually is still in the research figuring out like which of the encoder or decoder to be decided. For now, we are planning for the encoder, decoder, and hi-fi GAN decoder. So one fundamental thing is like try this specific architecture. We need large amount of the data. That is the fundamental thing. We already stated that this open source corpus which are available is actually like biased and not having like enough corpus for the low resource languages. So one of the another contribution towards the research, the data collection is placing it. So the idea is like from the YouTube, take the audios as well as like subsequent subtitles. So using that, we can actually like do the training. So we have the collector module which connects the YouTube videos, which can actually like extract only audio, until the video content and download the subtitles. Then we have the aligner, which can actually like different subtitle formats are there, like VDT, JSON3, SRT things. It will actually combine them into a single uniform format and eliminate certain like files which doesn't have falls under the category. And finally, we have the validator, which actually like validates whether the given parallel corpus or one translation to another translation making semantic meaningful or not. So that validator architecture has been actually detailed on another side, where we are actually using a sonar embedding. It's a embedding method wherein latent space we can have speech as well as text in the same space to see the semantic alignment. So using that sonar, we're actually like validating the entire parallel corpus. Finally, we're ending up with the accurate parallel corpus to do that. So the idea is to go for collecting 64K hours of audio and corresponding text data. So that 25% 25K amount of data is actually open source collected, and 60% in-house we are planning to download into it, covering these many countries of the region and the language of 35. So these are the subsequent reference. Thank you.
はい、発表ありがとうございました。質問ある方いらっしゃいますか？
Yeah.
Mr. Barathi, thank you for your idea. And so, in the problem statement section, you mentioned something about BFS and DFS, right? Like breadth first search and depth first search.
Yeah. Yeah.
So can you please explain how do you plan to incorporate them in?
Okay. Let me just like try to give the clarity. I'm not doing depth first search or breadth first search. I refer the terms breadth first approach, depth first approach. So like in terms of like ChatGPT or large language models, when we take Gemini, etc. So they actually like try to make the knowledge to the model for 100 and more languages. So when they actually do that breadth first approach, so the model's ability to learn more knowledge is actually like getting reduced for the specific language set. To avoid that, we are proposing a depth first approach where take a very set of limited languages for that create enough corpus and make a model to learn the maximum benefit of it. So, sorry, it's not search, it's approach. Yeah.
And another thing is, so you are collecting frequently data set by using YouTube videos, right?
Yeah.
So how do you deal with the licensing issues?
So there are like multiple things we have done it. So the YouTube videos, whichever is actually like ready to download, it's actually like doesn't require a license, but we can actually like use it. We cannot actually like share the data out, and we're also like planning to do some shares based on those. For that, we applied for the YouTube research program. So once we receive that, we can actually like download the license part of the videos also. So whichever is actually like not specifically licensed in terms of like a specific content ownership policies. If not that, we can actually publish it. Yes, we could actually like free to use it.
Thanks.
Anybody want the next?
Okay, so of course, these are things that we can talk more carefully, later together. And I know that we're still sort of, specifying what exactly, like what should be the exact weight of the whole research. Because even now, when I see your presentation, I'm a little bit afraid that this is too much for one PhD, right? And okay, but let me just ask a few specific questions. Right. So first, we say that we want this to be multitask, right?
Yeah.
Multitask, meaning so for example, models like Gemini or GPT 3.5, they are you can call them multitask in the sense that they're not task specific, right? They were trained on instruct training or something, and basically any task you give them, they will produce some kind of output, right? So the first question is, do you want this model to be, let's say, task in specific? So just like the generative AI model, generative like LLMs, or do you want this to be a specific, like multitask in the sense that there will be, let's say, I don't know, 4 tasks that this model will be able to solve?
So here we are specifically focusing on the 8 tasks, which we actually like listed down. And the 8 tasks, we are not actually going in the generative approach, like we are actually went in the breadth approach. In the breadth first approach, the decoder itself has been actually like trained for doing it. So we are not actually like doing it. The decoder is the common. We are adding an additional adapter layer. So that adapter layer will take care of the different tasks. So it cannot actually perform anything more than a specified task.
So not just those 5 or 6 tasks.
Yeah.
Any others? Or only those?
Only those. It will perform only those.
Okay, so why those?
Okay. So this actually like generally like includes all the components of text and voice related application. So it's like voice translation can be performed, and voice to voice translation can be performed. Text to text translation can be performed. Text classification can be performed, which means that we can also perform the voice classification, so which falls under the emotion or sentiment analysis and etc. And also like speech to text we can perform. So since it's actually like at most includes all the perspective of core NLP tasks have been considered.
If you so okay, I can understand that these are the tasks that you want to cover, but of course you know that each of those tasks is actually like a super general task. Like the text classifier, like you can have any kind of classification, right? So sentiments, cyberbullying, review, whatever. Right? So do you want this model to be able to handle like any text classification or any specific type?
No, like we are actually specifying to emotion, gender, and language. Why? Because like as we stored in the problem statement, the current models are actually like trained without handling any bias. So we are planning to train the model with respect to like all these parameters bias handling. So like equal amount of gender balance, equal amount of language balance, and equal amount of emotion balance. Since we are already taking the labels, the same we can actually use it for doing the classification. So that ultimate objective would be like handling this limited gender identification, language identification, emotion. That's it.
Okay. So those, let's say, general 3 areas.
Yes.
Okay. Okay. Well, so this is a very, very wide area that we want to talk about. And of course, you're collecting your own data that you want to make and use. But those tasks are, well, both very general, and there are there's a wide area that you're covering with this. It means that there are many other data sets that you could and actually you should use for comparison.
Yes.
So do you at this point, do you know of any other those multimodal, multilingual, multi data sets except from the one that you collected right now?
So like for now, generally like this multilingual, even including the quant and as well as like seamless parenting. So those are actually like including the Gemma variations. They're growing generally on the fluence purpose, like how it is actually performing on a different task, and independent on different. For example, if we do the emotion classification, it would be like IMO cap kind of data set they would be like using it. So benchmarking will use the same, but this also like we're actually listing out. So where A bar is actually like related to the Indian language data, YouTube data, which is already collected and having 9.2 levels of data. And hopefully, libre speech, speech to text to speech. This also we have. So we'll be benchmarking on this purpose. Test set alone.
Okay. So you want to try, like in your, let's say, evaluation, you want to use all of those data sets or at least few of them, right?
Yeah, a part of it. The like the as mentioned here, like all this data doesn't like handles the bias. Like more actually like male dominated, like 80%. So that has to be like avoided. So I'm planning to actually like use only certain portion of it, but use all the test corpus as it is to prove.
Okay. Right. So also, I got a little bit of mixed feeling about what is exactly the thing that you want to create. So from the beginning, you're talking about models like ChatGPT, Gemini, and others, and then you're switching to explain this, and this is basically a multimodal solution, right? Because you have separate model for voice detection or for voice processing, right? I think I saw somewhere the wave to vector or something, right?
Yeah. So that's the components. So this is the way to make the encoder pad and the decoder pad. But it's all actually will work together. So it
will work together, but it's not one model, right?
It is one model.
So you want to somehow combine wave to vec with some other text only model.
Yeah. So like for example, when we do the speech to text, so we have the text which actually can understand with the text encoder, and the speech you can understand the voice encoder. Now, in order to align this and this, we are actually sending the speech through length adapter to make the alignment. Once we alignment, the text decoder acts as a shared semantic space which share the knowledge with both the speech as well as the text. So this combined as a single model.
So, how many other multimodals, right? So not just multilingual, but model, and multitask models are there already?
Yeah, I'm working on that literature survey. For now, the reference I made is actually one variation is actually like one, so it's actually like sequence of model. Another variation is actually like JAMA 3 and E4B model, and another variation is like seamless model. So these are the three primary models we're actually like working on. All remaining were actually under the cascaded models. It will be like kind of late fusion method they are using to make it as a multimodal.
Okay.
Thank you.
はい、では時間なので、これで終了にしたいと思います。もう一度ガルさんに後ろお願いします。じゃあ、これで、すべての